One of philosophy's age-old puzzles is why there is something rather than nothing. Why is everything here? What is the purpose of the cosmos, everything that is, was, or ever will be? Is there some big purpose behind it, or is it just a fluke with no meaning at all? Is it even necessary to have a purpose? This has been a perplexing question, possibly spanning all of human history. Perhaps early people sat around the campfire debating the issue. Finally, any conclusions frequently entailed the metaphysical. A question that theology and philosophy have taken up and expanded on. However, within science, it has often been confined to one basic idea: the cosmos simply is, and does not require a reason or explanation. Hello and welcome to Zeey. Subscribe to our channel and ring the bell to receive our daily videos. Whatever your feelings are, there is a deeper layer here in the physics of what we know about the universe and its beginnings. It's not so much that the cosmos exists as it is that it exists as it does. Or to put it another way, why didn't the universe fail? Of all, failure is a relative phrase. What is a failed universe when there are no other universes to compare it against? Is the word fail even applicable in a universe? The outcome is simply the outcome, and that is all there is to it. So arbitrary though it may be, we could establish a ground rule here. This difficulty, known as the fine-tuning problem, is frequently placed in the context of life. How did everything come together so perfectly to allow life to emerge and intelligence to blossom? That's extremely intriguing and maybe significant, because intelligence is the universe's ability to see and, to some extent, know itself. I'm not sure what that says about the cosmos, though, because we don't fully understand how it works. If we can't understand it, it doesn't seem to understand itself. Aside from that, we'll use it in a different context here. Rather than starting with why life can exist in the universe, we broaden our scope. How is the universe balanced in such a way that complex matter can exist? This is a difficult issue because there is no ready answer, and the reality is that it almost didn't happen. The cosmos could have done one of two things to short-circuit itself very early on, and either would have stopped the universe we see around us, and no one knows how or why the universe did not short-circuit. Antimatter is used in the first of these short circuits. We know there is antimatter because we can make it. It's merely the inverse of atomic charges. When matter and antimatter atoms collide, they mutually annihilate, resulting in a full conversion of matter to energy. We also know that antimatter may be formed in nature. Massive positron fountains of unknown origin exist in the Milky Way, creating a light-year-long torrent of annihilation when they collide with normal matter. However, there is a mystery here. According to what we know about the Big Bang, it should have produced equal amounts of matter and antimatter. It should have been symmetrical, with a 50-50 split. However, it did not do so, or we would not be here. Instead, there was an asymmetry in which there was slightly more matter than antimatter. Thus, while a huge annihilation most likely occurred, there was matter left over, which is all the matter we see today in the cosmos, and we are formed of it. A relic from the violent beginnings of all that is, was, and ever will be. But if that hadn't happened, if there had been real symmetry, the universe would have ended with a tremendous bang and a flash, as every matter created was annihilated by its antimatter counterpart. After a little moment, there would just be nothing here. If there are multiple worlds in a multiverse, which we may never be able to verify or rule out, this may be how most of them proceed if whatever allowed for asymmetry between matter and antimatter is not the norm. Another possibility is a sliding scale, in which certain universes have more matter and may exist initially as merely a black hole, while others have less matter, resulting in a universe with significantly less total gravity and fewer, if any, galaxies. Such a cosmos could consist of sparse clouds of hydrogen and helium, with few stars, no planets, and no life. Such a cosmos would never be able to perceive itself. Another unanswered question is what function dark matter plays in all of this. The WIMPs are the best, but not the only theory for dark matter. Weakly interacting large particles, which like neutrinos, lack any means of strong interaction with other particles other than gravitational interactions. However, the antimatter problem enters the picture here as well, because a WIMP, a slow-moving particle with mass, should have a counterpart. In other words, anti-dark matter should have followed the same rules as regular matter and annihilated with its counterpart. However, it exists and constitutes the vast bulk of stuff in the cosmos, therefore asymmetry appears to exist with dark stuff as well. This is purely hypothetical until someone discovers what dark matter is. Another approach, while not exactly in the same vein, is to ask why the Big Bang happened at all. We don't know what caused it, what prompted it, or what occurred before it, if that's even a question. We only know it happened, and it does not appear to be repeated in this universe. As a result, we don't know how frequently large bangs occur. They may happen all the time throughout the multiverse, or they could not. But we can say that if whatever causes them is rare, the universe might not have arisen at all under different circumstances. Or perhaps it just happened once, which is not a far-fetched possibility given that time is a characteristic of the cosmos. Without time, it's possible that only one Big Bang formed in an instant. We simply don't know. Another possibility is that all universes created by large bangs happened all at once in the multiverse, albeit this is highly speculative. However, it is possible that the true source of all enormous bangs was the beginning of time, whatever time it is. The other possibility for the cosmos short-circuiting is even bizarre than antimatter, and the reason for it is just as enigmatic. The cosmic microwave background radiation hints at a situation that existed during the Big Bang. It demonstrates extremely minute temperature fluctuations of unknown origin that may have dictated the overall structure of the universe. If the temperature remained constant, we would still have a universe, but it would be considerably different from what we have now. The conditions of the Big Bang and the formation of the first matter were nothing short of astounding since they occurred so quickly and were subject to some extremely exact criteria, which were heavily dependent on and determined by heat distribution. The Great Bang created helium, as well as hydrogen and trace amounts of lithium and beryllium. But helium is crucial here because forming a helium nucleus under these conditions necessitates a slightly constrained temperature range, billions of degrees, but not a wide variation. This circumstance was generated by photons colliding with particles during the Big Bang's conditions, and it also necessitates the introduction of a neutron, which would decay if not linked with a proton. The end effect of all of this physics is that in order to have primordial helium, it had to happen within a few tens of minutes of the Big Bang, and that's it. It would not happen again until the first stars began to fuse and emit helium. Then, as the temperature plummeted, the expansion of the cosmos at the moment halted the synthesis of primordial helium. It only took a few minutes for all of it to happen. However, something happened during this time that resulted in the very little temperature differences as opposed to full uniformity. If it hadn't happened, we'd have a universe of equidistant hydrogen atoms incapable of clumping and forming stars and galaxies, instead remaining that way either eternally if the proton doesn't decay or in the long future if it does. Even if there is a lot of normal matter within it, it would be a lattice universe where nothing happens. There are other possible ways the universe could have short-circuited, such as if the period of inflation, which is required to explain what we see with things like cosmic background radiation through observation, had never stopped, the universe we know would not have come to be, and it would have had to slow down to the expansion rate we see today. And there are many other aspects of the fine-tuning problem that are problematic even before you get to the subject of life, or rather the existence of matter in the configuration that allows it to fuse atoms higher than helium in the cores of stars. So what brought all of these elements into play? We don't know. It's possible that this is the only way universes can exist, and we simply don't grasp the underlying reasons why things are the way they are. Another possibility is the multiverse, in which there are many other types of universes, and this one just happens to be the lucky one for life, whilst the majority are not. Alternatively, it is fine-tuned, pointing to a simulation or a metaphysical genesis. But one thing is certain, when we examine gravitational waves as probes into the earlier history of the cosmos than we can observe through other means, there will either be answers or not, and with an answer comes a slew of new questions, as is so often the case in science. Alright everyone, here's where the video ends. Thanks for watching. Is there anything you'd like to say? Tell us in the comments. Subscribe to our channel for regular, in-depth studies of the fascinating, strange, and unknown parts of our beautiful universe.